I was asked recently for help in how to interpret the performance graphs in GemCut Studio in order to optimize a design. So the design we're working on now has been loaded and we've got it here. And to see what we're working with is the tilt performance graph. So first thing to do is we'll go into Tools and Tilt Performance and bring that up. So right away we see the design itself ray traced and being tilted automatically, and a graph showing values for the performance along that tilt. Now the range in tilt can be set and changed from anything from 90 degrees to 0 if we don't want it tilting, but I'll just leave it to the 30 degrees tilt default that's in the app. And so what we're seeing here in this graph is tilt along X and along Y. So while the cursor is showing us where the design is at the moment we're reading that performance, so we'll see that tilt X is sort of tilted up and down, and then back to center, and then tilted off to the side, and that's tilt Y. So right away there's a lot of data to be gleaned from this one graph. So if you're starting out, something you can do is sort of declutter it, and as we're starting out here, we're just going to be removing some of the graph curves that are less important to focus on. So the first thing you'll notice is there are lots of colored solid lines as well as dotted lines. So the dotted lines are the equivalent data for whichever curve we're looking at, but only for the region underneath the table here. So if table performance is important, those dotted lines are important, but as we're trying to go less clutter here, we're going to get rid of the table value, so we'll untick that. That gets rid of all the dotted lines. As well as we'll untick this cosine brightness. Cosine brightness is a bit more of an advanced metric on reading tilt performance, so we'll get rid of that as well. And that only leaves 3 curves. The white-gray curve is our overall isometric brightness, so that's sort of brightness regardless of the light we're using. That's light coming in from all over that makes it back to the viewer. So that's a good general indication of the brightness of our design. The orange curve is the windowing value, and the purple curve is head shadow. Now, the one way to look at this is the value that we get for overall brightness is the maximum possible brightness, 100%, minus any losses from windowing and minus any losses from head shadow. So the value you see here will always be equal to 100% minus whatever the orange curve says minus whatever the purple curve says at that tilt. So when we lose brightness performance, it's good to look at where we're losing it. Losing it to head shadow could arguably be said to not be as important because a little bit of head shadow can contribute to contrast patterns, which then contribute to possibly scintillation, and not overall detrimental. A design that has pure brightness might be a bit boring to look at and might suffer from lack of scintillation. So the real culprit we'd be looking at is windowing, and that's pretty much dead on avoid as much as possible in a good design. So we can see on this design that the windowing is actually sort of the highest level curve all around, especially at face up tilt. So that's something we're going to try to alleviate. Now, seeing the windowing should be slightly obvious when looking at the design. Let me just close this and we'll just have a look at the render view. Now, we'll see that this design, which has been colored, sort of aquamarine colored, has a lot of areas here which look a bit dark. Now, whether that's an influence from head shadow or just the overall color of the gem might not be obvious to a beginner. By tilting it, we'll see a little bit of light coming through and a bit more action coming through as we tilt it. So that should be a hint. But if you're just starting out and looking at this render graph, it might not be obvious. If you really want to identify your head shadow versus tilt windowing, one good thing to do is go into the render and in the background color tab, tick the separate window color and then choose something for your window color that's obvious. And this makes it a lot more obvious that most of this design is actually windowing. So that accounts for where all this high amount of windowing comes from. Now we'll see it here, and it becomes a lot more obvious that a lot of this design is windowing. So for now, I'm just going to leave it off maybe, and we'll just kind of go by eye. Okay, so how do we fix this? Is there anything to do with this design? Well, the next step would be to try to optimize it. So we can do that simply by just using a tangent ratio of the angles that were already created and see if there is a better possibility in the refractive index that we've chosen. So I'm not going to touch the refractive index, so we'll just bring up Tools Manual Optimizer, and this shows us our design as well as other possibilities of tangent ratio angles. At the equivalent of 100% and 100% of our angles, we'll see our original design, and if we select it, we'll see the same tilt window graph that we had in the tilt window tool without the legend, so it might be a bit more confusing when you're looking at this to see what these mean, but because of the time we spent in the other ones, anything unticked or ticked over there will appear in this graph the same way. So this lets us just sort of focus on more of the tools at the same time without having to worry. It's sort of implied at this point you know what these curves mean. So we've got the windowing, the brightness, and the head shadow. And so here's our design as is. Now right away we can look at this possible combinations and see that right alongside to the left here are sort of more luminescent versions of it. On the right, it seems like the windowing gets even worse with a lot of sort of head shadow reflection, that black in the middle. But over here, while we do have a lot of head shadow, the patterns are interesting. It's not just a giant blob in the middle. This might be taking it a bit too far where there's a big ring of black, but over here, this whole column of designs looks okay. There's interesting contrast patterns, especially in things like this where there's nice little designs appearing. So what we could do is just select one instead and see what it looks like. Now right away we see the performance graph looks a lot better. We've got a very even, admittedly not very high, isometric overall brightness, and the reason for that is partly because of a bit of windowing and a bit of head shadow coming through. Now we can see most of the head shadow here as the black, and again it appears as contrast patterns, so that's not the worst thing in the world. We should be able to take a little bit of a hit on overall brightness for interesting contrast patterns. So if we play around with this, one thing we can notice is that windows in this area really easily, and if you need help with the windowing, feel free to leave that separate window color on to visualize this, but right away it's kind of typical of windowing where the contrast just goes out on the design and you can start to see the background color. So if I'm dead on, there's no windowing, but as soon as I move off to the side, there's a lot of windowing, and we sort of see that happening here where the windowing is very low at the beginning, but then it grows as we tilt and quite high. So maybe this solution is not the best. There might be a solution between 90 and 100%. So what we can do is just select this range here from 90 to 100 and drag it, and that will expand using those two values as extremities. So we've got 100 here now and 90 here, and then a few little options in the middle sort of halfway, so it kind of digs into possible options. So what we could do is just select any of these, have a look at the graphs, play around with the tilt, so we can see that it doesn't quite window quite as quickly for something like this where there's not a lot of windowing happening. Probably starting to come off along the sides now though, as overall windowing is a bit higher. So it gives us options to choose something that we might find better. And in some cases with some designs, especially on low refractive index materials, there just isn't a perfect design that has no leaking or no head shadow. You've just got to sort of play with what you have, and already anything of here would be better than the 100 we started with for this design here, which has, you know, good values when we're tilting, but sort of very windowed when we're looking at it from the start. So anything here would probably be a better option, and so you could select something like that here and apply, and then work with that and cut these angles instead. So that's just a quick example of how to use the tilt performance graph to optimize a design.